welcome. Thank you for coming in. I don't know how long your night was last night. Mine was 3 o'clock in the morning. So I definitely enjoy St. Petersburg. Right. I would normally start this with a video, but because we only have half an hour, I'll just give you a quick overview of who Perforce is. Does anyone know Perforce? 1, 2 people. Does anyone use Perforce? At least one. Okay, very good. So Perforce is a software company, American-based, with offices in the UK, where I'm based, and Germany and Australia as well. And we do version management. We just version stuff, which is what the talk is about, versioning files. We do this for all kinds of things. Software, game development, obviously, that's why we're here. All the major companies that create games, AAA games, but also other games as well, tend to use Perforce, because it's the only tool out there that can scale to the sizes that we need in the games. But it's not just games, it's also electronics. If you build a chipset, something like that, the big companies of Intel, AMD, NVIDIA, and so on, they all use Perforce to keep not just the firmware, the software installed, but also all the layouts for the game chip development itself. And the same is also true for all the companies that create mobile phones. So if you look at Samsung or Apple or HTC or Ericsson and so on, they all use Perforce as well to store all the stuff in it, inside. Let's start with the silly question. Why do we do version management at all? What's that good for? Any ideas? Yeah? No one? No one uses version management? You got to use something. You have any idea why you do this? Well, the first reason for me was make a backup of stuff. If I have a big project, I change files, and then I realize I did something wrong, and I need to recover it again. If I don't have a backup, then I lost my project, and all the time is wasted. Another reason is collaboration. So for simple version management, you can just simply copy the files to a file share. But if you work together with other people, big teams, starting with 2 people, 5 people, 10 people, and there are projects out there that have thousands of people on it, then without a control of who can access what, without the possibility to make sure that we can merge changes together, without the possibility to control who has access to which part of that, you will fail in your project. And the last part is, in case something goes wrong, or in case you want to find out what happened here in the past, why did someone make a change, you want to go into that archive as well, because in the way a version management tool is an archive of all the changes you have made over the time to your project. And you want to see what exactly went on inside that project. So what is version management actually? All right, so let's start things very simple. You have a project sitting in some root directory. And you have a bunch of folders inside that, and a bunch of files. This is how you start out. This is your project in there, and that's what you work on. When you version this, it winds up in some kind of a database. So you start out with grabbing a bunch of files, and you're checking them in, submitting them, committing them, whatever you want to call that. So this is a starting point. And then you make changes to your project. You add new features. You remove bugs. Hopefully not both at the same time. And while you do that, you're going to modify some of the files. Probably not just every single file in that, but just a few of those files together. But typically there will be more than one file you're going to touch. So if you make a change to your C++ files, for example, you might modify the header files and the C++ files. Or you might modify a test plus all the gaming assets or something like this. Every single one of these, we're going to add 1, add 2, add 3, are your commit states. And ideally, each state of that is a state of your game or of your project that builds, that tests, that works. It's just each state that has a feature more or a bug less. That's the deal we're working with this. So, and these control points are important. So that's the basic idea of every version management tool you can find out there. Take a bunch of files, move them forward in controlled stages. Now the fact that each one of these states can build, test, that's up to you. Version management tool can't do that. But you typically plug this into a continuous integration engine build system that can automatically make sure that these tests is good, and if not, it will throw it back again. All right, let's have a look at that. So this idea with the having backups of the different files, that works fine for one single person. What happens if there are more than one person involved? So here's a very simple idea of I start out with a simple C++ file and build the style engine for my game. Okay, I make my change to that. Well, it works, it's fine. But then my colleague comes along, and gee, I'm going to make changes to that. In this case here, user authentication makes sure that, because it's an online game, that the user is correctly identified. Now, while she's doing this, I make different changes. I make changes of the kind that whatever I add loot to that to make sure that the game is more interesting. What do I want to happen now? Both people made changes at the same time. Ideally, I want to have this. These changes merge together so that I can have a working game afterwards, and I don't have to go through it line by line and check it out. But have you ever thought about why that actually works? What does a version management tool give you that ability to merge those changes together? There's a trick behind that. And the trick is this. We have a common base, the starting point of where we started out with that game, or with that file. Then my colleague made changes, I made changes. I can calculate from that simply which changes were made in that, and then the merge engine can go to take these things together and calculate exactly what the result of that is. So that's why merging automatically works in these cases, because we have a common base. And the important thing for a version management tool is to be able to provide you with that common base, even if you have created the branches across that and the merging changes across branches as well. Right? So that is text-based, source code-based merging. Right, but a game is not made from source code alone. So what do we do with binary files? And most games consist of, I don't know how you count that, size of volume, something like that, 95 and 90% of just binary files of your binary assets, of your movie, and sound files, and textures, and all the other bits and pieces. Well, these files, and generally you can't merge. So the only way you can get around that is to lock the files. So your version management tool has to have the ability for those file types, specifically make sure only one person works on that. If that is not the case, and you have two people working on the same file by accident, then one of them will lose out. One of them will lose their changes because you can't merge them in. So in order to make a game, you have lots of different components in there. You know that yourself, you're all game developers. So I've got the source code, I've got the music files and everything else, but they all belong together in one set. Now, if all these different files live in different silos and different kind of repositories in there that are independent of each other, then you will find very quickly that as you build the games together, there might be situations where someone made a change not compatible to someone else's change. And now you have a problem finding out, well, I made a change here, but at the end, we've changed the engine by now. They don't work together anymore. How can you find out what went wrong? How can you prevent it from happening if these things live in different boxes? Well, you can't. What you're looking for a game is something that we call a single source of truth. One single place where you can store all the files. Text files and binary files, every single aspect of what you have to do inside your game. That's not so easy, though. Because I ask myself, why is game development so hard? I mean, besides the obvious reason, coming up with the idea and putting the game together and making sure that it actually works and finding a publisher and so on. Why is it so difficult? Okay, I would argue this is part of the reason for that. The typical AAA game, I'm not sure you're involved in AAA games in any shape or form, but these numbers here, hundreds of thousands of files, terabyte of source code, going to that 50 gigabytes change a day, which you have to deliver to every single user out there, and there might be hundreds of them out there. That might be part of the problem. Now, these numbers are conservative. They are not the reality anymore, because these are based on HD games. If you go to the big studios and ask them, they're not talking HD in games anymore. They're talking 4K games. Take those numbers by 4. We're often talking about 10 terabytes for header vision, a total repository size of 500 terabyte, or something like that. There's huge numbers in there. Now you might think, he's talking rubbish. I'm developing games for mobile phones. Well, I care. My project is 50 megabytes in size. Who cares? Well, okay, so this kind of mobile phone, that's an old one, iPhone 6. 15 years ago, this would have been more powerful than my laptop. Was at that time. The screen resolution of this is not quite HD. It's not far off, Retina screen. That's not true anymore. If you go out in the shop and buy the latest mobile phone, the resolution of these things is higher than that. And the first 4K mobile phones are out there. Now, your customers will demand that you fill those screens with nice high-resolution content as well. Not just a simple click and then two-dimensional games anymore. They want to see big, fat content on that. The result of that is these numbers. So even if you're working on a mobile phone game, you have to think about, well, my little world where I can just put everything in a little box and work with 2 people on that might not necessarily be true anymore in the future. So there comes consequences for these big numbers. One of them is at the beginning, every single time you check something in, you want to make sure that it builds, that it tests. By the way, if you don't do it yet, test-driven development makes a world of difference. I used to not bother about that kind of thing anymore, but I don't do any projects anymore without having a test for every single change I make to make sure that that still works if I refactor something or rebuild something in a later stage. But every single time I check something into our version control system, a build engine will kick off in the background and will take that and verify that it works. Most importantly, because I typically develop on my Mac, but the projects I build have to work on Windows as well, have to work on Linux as well, and all the other platforms. And I can't test that every single time. I leave this to the continuous integration engine that goes, builds the stuff, and makes it available on all different platforms. And for games, this is even worse. You have to have Xbox and PS4 and whatever other platform you work on. But typically you work on one single platform to make sure that it works everywhere else. But if these sizes of these files and the rate of change going in there is so high, then you very quickly come to the point where you can't build every single change anymore quick enough. But the rate of change going into the game is so high that the build engines behind it can't catch up. One of the consequences is that you might have one single big computer in the office that has your version management tool in it, and then you have a whole farm of dozens or even hundreds of big machines in the background that do nothing else but building all the time. The build engines are humongous in that. But if you can't build quick enough, then you don't know anymore if the check-in you did was good, works on every single platform. Can you figure out who broke the build? The problem is that the header revision of a game might not be stable. And if then QA testers come along and say, well, I want to go back, I want to have a stable version I can test on and go, someone just checked something in, I don't know what the state of that is, you have a problem. So what I just want to give you here are some ideas of how we can address this issue. None of them are perfect because it's not a perfect world. But most of these things have been true and tried and tested by many of our customers as well. It's just an idea of how you organize the source code and how you work together in this particular environment. Which particular form of these you will use is entirely up to you. It depends on your environment, it depends on your team, how well you work together, how many platforms you work on, and so on. All right, let's start with something very simple. Simple code line. And yes, if you come from Git, the errors are the wrong way around. So I have a state of changes. These are changes that I make to the game, to my project. And each time of that, I then go off and build and test it, and it works good. Everything's good. At the late stage in here, I have a stable change. Fantastic. And then I make changes. Lots of changes, lots of different kinds of changes in that. The question is now, of course, are we still stable? We don't know. So how can you address this? One of course is, everyone says, easy, use branching. Every version management tool is branching. We just branch stuff. The branching, there are a few things you have to keep in mind. Branching means my main team continues to work on the main line on the top, the trunk or master, whatever you want to call it. And then I'll take my changes offline. I'll make some other changes to that. That might be disruptive. I might be refactoring, some rebuilding, some rechanging of the engine or something like this along the line. And then comes the point where I deliver my changes. No point me having it in a different branch. I want to bring it back and again into the main game so that everyone else can use that. In the meantime, my game has progressed. If I merge my changes back in there again without taking care of all the changes up there, I'm probably going to wind up overwriting someone else's work. Or that might not fit, I will break the build. The ideal way of delivering my change in the development branch is to pull the changes that I've done beforehand down, so that at this stage I have the latest version of my project, my game, plus my new changes, and then deliver it back. That's great. But if you do this, you might have a problem. So short-lived branches, where you make a change and then deliver it back within a day or two, that's fine. Or it might even be hours or minutes. But if you have long-lived branches, where you live on that long-lived branch for 2 or 3 months before you deliver it back, then by that time, most likely, your project has long progressed. And now updating your long-lived branch with the latest changes is going to be very painful. You're going to spend days just merging stuff together. And that's going to break. So, hint 1, if you use branches, development branches, make them short-lived. Like this. So having short-lived branches in there, and just hope it changes in there, concentrating on one single task and then delivering it back again, will avoid the merging errors. Otherwise, you're going to hire people that do nothing else all day long and merging changes in. I've seen that happen, where every Friday is taken away just to merge development branches in. They do nothing else but try to figure out what happened during the week. That's a waste of time and a waste of resources. Right. Branches. Great. That works well for text. What about those game assets? Images, 3D models, sound files. Yeah, we locked them. We just said that. Across branches? That doesn't work. Many people have tried. Many people have asked us as well, can we please have a lock across branches? There's a logical problem in that. If I make a change to a file in the development branch, and then I check this into the development branch, is it now still checked out logically across all the branches? Or is it now finished? Do I remove the lock or not? Well, you could argue, I'm done with that, so I remove the lock. But then if someone else modifies the same asset file at a later stage in a different branch, then there's still a conflict. When you merge them together back to the main branch, then something's broken. Or it could say, well, okay, you have to have a database of all the files you changed and keep that across with that. And then I might go and build a development branch somewhere and realize this is going nowhere, leave it where it is, forget to check the files back in again, and the files are checked out forever. That's not working either. There is no easy solution around this. Communication, who has modified or who's modifying what, is the key. But in reality, what you probably wind up with is not branch those files. So how do you get around that problem? I want to branch typically source code files. That's the way developers like to work. And there is a way to do this. My preferred way of working in this kind of situation is what I would call a component-based approach. A component-based approach is where you break your big project down, which contains of all the bits and pieces. Now I said, single source of truth, keep everything in one single code line, one single repository. That doesn't mean that everyone has to always download all the versions of the files. If I'm a source developer, I build the engine, I don't need the raw formats of all the binary assets that I bring in, because I'm just going to use the compiled versions of that are coming out of the build queue. And if I am an artist building, working on this kind of stuff, I just need to run this engine. I don't care about the source code of that. So you can split these things into smaller chunks. One idea is thus to have a shared trunk with everything on it, and then break out smaller chunks on that and work on those. And that's quite a typical way of how people work with Perforce Helix. So an artist will just have the few files that they work on, and then bring everything else in, just mirror it in without changing it in a different branch. And the developer will have the same thing, just focus on their particular project they're working on with. An alternative way is to have a separate trunk for that. That's more typically used in the in engineering way. So if you work on chipsets or something like that, or big components that are made up of lots of the small components, they all have their own separate timeline. They work on them separately. They can be tested separately as well. And then at a later stage, you bring them together into the main code line as well, mirror them in, and work with that as well. So the component-based approach for game development works extremely well, but you have to know exactly how to split these things across. An alternative for that is trunk-based development, again, but now turning around the owner. So instead of having your trunk and everyone works on that, and that's where you want to have stable version of the game, you have a stable branch sitting above that, and you pull the changes across by cherry-picking them through a very thorough testing process. This approach has been used by some of our customers. What they require is the tooling in place to make sure that when they pull the changes, they can test them thoroughly and make sure, yes, this is a good test. And then the test people, the QA people, can just work on the released version of this plugin that, while the developers continue to work on the trunk and take the fact that the last version of that might not be stable. Last thing I'm going to add to that is a particular bugbear of mine, milestone branches. Have you heard of milestone branches? Are you using milestone branches? Are you using milestones? A few people using milestones. Very good. So if you're a game developer and you have a publisher sitting behind that, or the great public out there trying things out, and beta versions and alpha versions, early access and so on, then you want to have something delivered. And you want to have something ready that you can give to them. Now, most likely or not, in order to make that possible, you will have to cheat. Some things might not work. That room over there is not finished. I'm just going to put the wall in front of it to make sure that you can't walk into that, just to test out whether the engine itself works and whether that game looks nice or not. So you're going to have milestone branches. If you don't do that, and everyone else works on the trunk to prepare a milestone, you're going to put hacks in that, and afterwards you have to take out, and that's an issue. So having a milestone branch instead means that you can work on this separately, fix whatever you need to fix, put hacks in if necessary, or pull the changes down you want to do. So you have it separated, you can go back to milestones and show the progress on different milestones and that's a good way forward. And with that, we're done. If anyone wants to know anything more about Perforce Helix and why it works so well in the gaming development, then find me outside. But otherwise, I just have a minute left for questions.
Thank you very much.